Right, guys, this is our last lesson to do with circumference and circles. So write the title and the learning objective. It won't make much sense to you yet, but hopefully after I've done a bit of explaining, they'll make a bit more sense. So pause the video so you've got time to do that, and press play when you're ready to keep watching. So, we're calculating distance with revolutions. Now, it doesn't mean a revolution like the French Revolution or the Russian Revolution, where society decides to overthrow the establishment. I'm not talking about that right now. We are talking about a circle, and specifically we're talking about a wheel. Here's my wheel. These are the spokes. I found out recently that spokes are actually just pieces of wire. They're not fixed bits of metal. So if you take them out, they bend, and they're like just bits of metal wire, which is interesting. Or maybe it isn't, I don't know. Now this is a wheel, and a revolution, one revolution, is the basically it's one full circle. So it's one full turn. So if I just pick this wheel up, you see the red point at the bottom. If I turn it all the way, I have to pick it up again, all the way until it goes back down to the bottom, that is one full revolution. It's one full turn of a wheel. Now, if we know the radius of a circle, let's say it's 1 meter, which is a pretty big circle, you can find how far the wheel moves, the distance it travels over one full revolution by calculating the circumference, because the distance it travels is the same as the circumference. So to show you that more easily, I'm just going to go on to, oh, that's my YouTube channel. That's a bit, how did that get there? 4,300 views in the last 28 days. 77 subscribers. Whoa. Anyway, never mind. Don't know why that's there. Weird. Anyway, to show you how the revolution of a wheel works, I'm going to imagine this is a wheel. Well, it is a wheel. I'm going to pull this out, and you can see the circumference is equal to the distance the wheel's travelled from one full revolution. So the circumference is equal to the distance travelled in one revolution. I'll do that once more. There you go. Nice. So we can use what we've learned about circles to figure out how far someone might travel with a given number of revolutions. So let's take an example. Here we've got, let's go back with the bike. I like the bike idea. So this is, it's one of those old school bikes. We're not just talking like 1990s, we're talking 1890s, maybe even earlier. This is one of those bikes where, actually, let's make it a unicycle. It's a unicycle. Here's the saddle. Here's how it holds on, right? You see that? And plonked on the top of it is Javid. Hey! Hi, guys. Look, Javid's talking to us. Hi, Javid. Give him some hair. There we go. So Javid's cycling along is a unicycle. Now his unicycle is massive. It's like one of those comically big unicycles. And the diameter of the unicycle, so the distance from one side to the other going through the center of the wheel, diameter equals, how big can we make this in reality? It's 1.5 meters. Diagram's not to scale. So the diameter is 1.5 meters, which means the circumference, which is the distance around the wheel, what does that mean the circumference is? Pause the video and just figure that out. Circumference is distance around a circle. How do we find it? Pi times diameter. So pi times 1.5. I'm going to leave it in terms of pi for the time being because it's just a bit easier, it's a bit cleaner. Now Javid, he's on his way to school. It's the first day back after lockdown, and Javid thought, I'm going to celebrate this by getting on my unicycle. I'll show everyone how good my unicycle is. Something that I made in lockdown from tech. Why not? With this mental story. And so Javid's cycling to school, but he's not had much experience on the old unicycle. And he only manages 15 full revolutions, which means the wheel turns round completely, one full turn, 15 times before he falls off. Don't know why he's trying to cycle to school on a unicycle, Javid. It's just such a rogue move. Now, the way that we can figure out how far he cycled before he fell off is we can do this. Box method, circumference, revolutions. So I'm going to label the first row of boxes, the circumference, C for circumference, and I'm going to label the second column revs, as in revolutions. If you ever heard the word revs before, it's referring to revolutions. Now the circumference is 1.5 pi, and that is the distance travelled from one revolution. Now if Javid travels 15 revolutions, I'm going to write that there. And so to find the distance that he travelled, we need to figure out what goes in that box. Connection is obviously times by 15, and so we do 1.5 pi times 15. And if I do that into my calculator, I get 70.7 meters to 3SF. That's not a bad distance actually, Javid. Not bad at all. 70.7 meters on a unicycle, not bad at all, my friend. Good for you. So, this is our strategy for calculating with circumference and with revolutions. I'm going to show you some examples that you're going to have to use this strategy for shortly, but make sure you've written any purple pen notes that you need to, because it's not an immediately obvious thing to have to calculate with. I'm sure you haven't done it before. So when you're ready to keep watching, press play. Right, let's go with right. Here's example number 2. Example number 1 was Javid. Example number 2 is about Colin. So pause the video and have a go, and press play when you're ready for me to go through it. So the diameter of the wheels of Colin's Segway, just to be clear, a Segway is like, oh no, it's like one of these things where people stand and they hold on to, they stand there and, I don't know, you just Google it, it doesn't matter. So the diameter of the wheels of Colin's Segway are 0.68 meters. Now we should draw a diagram, but not of the Segway, we should draw it of the wheels. So 0.68 meters is the diameter. Colin goes for a ride, and the wheels complete 29,057 full revolutions, which means they go fully round that many times. How far did Colin ride in kilometers? Give your answer around 2 decimal places. So I'm going to do circumference and revs. So we've got to figure out what the circumference is for one rev. It should really be distance here, shouldn't it? It should be distance, and this box represents the circumference. Distance and revolution. Sorry guys, I'm kind of making this up as I go along because I've never actually taught this before, but let's call that distance, and that's the number of revolutions. So the first box for one revolution, that is the circumference. So we need to find what the circumference is. Circumference is distance around a circle. How do we find it? Pi times d. So 0.68 pi. So that's how far Colin travels from one revolution. But you can see actually Colin's wheels do 29,057 revolutions. It's a huge number of revolutions. So then to find how far he goes, we're going to find what goes in this box here. So the connection is 29,057. Definitely a calculator question. It's telling us to round up to decimal places. So 0.68 pi times 29057. And I get this number here, 62073.97 stuff, and then more stuff. And that's the number of meters. So I'm going to zoom out a little bit, and this is where your converting units of measurement will come in very handy. So Colin travels 62,073 and some other stuff meters. In kilometers, we have to do box method. Again, we write meters, kilometers. Bigger thing is 1. There's 1,000 meters in a kilometer. We write down 62073. Divide by 1,000. We divide by 1,000. We get 62 point. Have I started them in the middle of the box? 62.07. And it's only asking for 2 decimal places, so 62.07 kilometers. And that's it. That's how far Colin rode in kilometers. There's quite a lot to that question, so make sure you've written all the purple pen notes that you need to, and when you're ready for the next example, press play. E.g. 3. Have a go. This is very similar. This is incredibly similar to the Javid example. Yeah, all right, well, fine. Have a go at this on your own. Pause the video and press play when you're ready to keep watching. So as always, a diagram of the wheel of a unicycle is 0.67 diameter. Sorry, not diagram. Is 0.67 meters. It's always good to draw a diagram. So that's that. Lisa tries to ride the unicycle and manages to go in a straight line for 95.4 meters before falling off. How many complete revolutions did Lisa manage to cycle? So first of all, let's acknowledge she cycled further than Javid. I didn't think Javid did that badly, but Lisa's done better. So I'm going to draw my box method. And I'm going to have distance and revs. Remember, first of all, we find the distance for one revolution, which is otherwise known as the circumference. To find the circumference, pi times diameter, 0.67 pi. So that's how far Lisa goes after one revolution. But she manages 95.4 meters. So this time, we're writing that in the distance column. Now, can you see the connection for here? The connection vertically is not nice at all. But going this way, just do it, divide by 0.67 pi, because anything divided by itself is 1. Over here, divide by 0.67 pi. And if we do that, 95.4 divided by 0.67 pi, I get 45.32. How many complete revolutions did Lisa manage? The answer is therefore not 42, 45 revs or revolutions. So again, pause the video and make any notes that you need to, and press play when you're ready to keep watching. Last example, e.g. 4. Have a go and hit play when you're ready for my explanation. The radius of the front wheel of Dan's bike is 60 centimeters. Dan goes for a cycle and travels 69.07 kilometers. Sheesh, that's a double unit conversion straight away. I'm thinking centimeters to meters and then to kilometers. How many full revolutions did Dan's front wheel complete? So our strategy, before we draw the diagram and all that stuff, revs, distance, 1, we need to figure out this is the circumference, and we know the total distance he travelled, 69.07 kilometers. So we need to figure out what this is in terms of centimeters. 2 conversions, 2 box methods. So we've got centimeters, meters, meters, kilometers, 1,000, 100. 69.07 kilometers. Connection is divide by 1,000, divide by 1,000, and we get 0.06907. What's my mistake there? Complete nonsense. Obviously it's times 1,000. What am I doing? Guys, I'm sorry about that. Really sorry. Be better than that, Mr. Kempner. I'm trying. So it's 69,070 meters. So now I'm going to write that here in this box because that's how many meters I have. 69070. And then I'm going to write it, the conversion, times 100, times 100, and it's 6907000. 6,907,000 in centimeters. Fine. So remember, this question is all about finding how many revolutions did this front wheel complete. So now we're going to draw our diagram for the wheel. It's only 60 centimeters for the radius, which means it's how much for the diameter? It's 120 centimeters for the diameter. So therefore the circumference is 120 pi. Wow, 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 wow. So last thing we've got to do is we've got to find the connection. Divide by 120 pi. Divide by 120 pi. Get my calculator out. 6,907,000 divided by 120 pi. And that is equal to 18,321 point some stuff, but it's asking for full revolutions, so the number of revolutions, number of complete revolutions is that. That is a spicy question to finish on, guys, and I think it shows it's a nice way to finish this half term. Obviously you've still got tomorrow's lesson, but the fact that you're doing the box method for such a complicated thing involving circles is incredible, given that you've taught yourselves all of this since the start of lockdown. So well done, you should be very proud. Good luck for the Hegarty Maths task, and as always, don't hesitate to email me if you've got any questions about anything.